Euler's method review. Anytime you're looking at Euler's method, you're talking about y over x is equal to what? What's the change in y over the change in x equal to in algebra? Slope, right? Slope m. So if you look at an example like 14, this dy dx is the same as the slope. So what you can do is you can put an equation like f of xy, this thing, that is your slope. Slope is the change in y. It's the next guess minus the previous guess over the change in x. Next guess minus previous guess. But if you're doing the same x increment every time, you can, instead of saying x of n plus 1 minus x of n, just change that to what? H. That's how different the x's are. Okay? That's your slope for that. So then what I would do algebraically is cross multiply, so you get h times f of xy, which was your slope, right, is equal to y of n plus 1 minus y of n. If we're solving for y of n plus 1, you'll just have y of n plus 1 is equal to f of, f of xn, y times h, and then plus y of n. And that's Euler's formula. What it is it's kind of a forceful way. If this is my graph, and we're breaking it into x0, x1, x2, x3, what you're doing is you're starting off here, skimming the edge, and ending up there. Then you're mimicking the slope at this x1, mimicking it to get to the next place. And mimic that slope to get to the next place. You see how you get further and further off the further you go, but it's a pretty decent approximation. Now, if you're going from 0 to, I'm just going to go to, let's go to 0.6. How many of these regions are there? 3. So you're going to go to 0.2, and you're going to put a 0 in. You're going to go to 0.4, put a 0.2 in. Then you're going to go to 0.6 and put a 0.4 in. You stop the time before you get to the last one. So if I'm taking a look at this example here, the way I like to start is I like to start by what is my first x0, what's my y0, what's my h, and what are we looking for? This is what we're trying to find. So we start with the first x in the problem. It's given to be 1. First y is given to be 4, and we're incrementing by 0.2 every time. So then I just write the formula y of n plus 1 equals y of n plus h f of xy. Okay, let's personalize it for this particular problem. It's y1, which is what we're trying to find, is equal to y0 plus h times f of xy. Now that is going to be the slope equation, which we're saying is 2 square root of x0, y0 minus y0 over x. And then now all I have to do is plug these values in to figure out what that first one is. So y1, y0 is 4, h is 0.2, 2 times the square root of 1 times 4 minus 4 all over 1. Let's see, yep, 1. So this is, square root of 4 is 2 times 2 is 4, 4 minus 4 is 0. So this, unfortunately, is still going to be 4. Right? Does anybody else get that for the first one? So y1 is equal to 4. So that's weird. Turned out to be the same. Will the next one be the same? No, it'll be different because when we do this next step, then what's going to happen is you're going to have x0 is one notch higher, so instead of 1, it's going to be 1.2, and that's going to change it. Kind of weirdness that it turned out to be the same, but now we're going to find the next one. So you would keep doing that. You'd do that 3 more times, I believe, to solve this one. So that's an overview of Euler's method.